Hello and welcome to Excellence Link Academy. So for today, we're discussing about organic chemistry as a course. So let's discuss about the concept of organic chemistry. So what is organic chemistry? By definition, organic chemistry is simply the study of hydrocarbons and their derivative. It involves the study of covalently bonded carbon compound. In the study of organic chemistry, the major element there is carbon. Why do we consider carbon as the major element in the study of organic chemistry? What are some of the special properties that make carbon a unique element in the study of organic chemistry? Three reasons. Number one, the ability of carbon to catenate. So one of the reasons why we consider carbon as a major element in organic chemistry is the ability of carbon to catenate. By the ability of carbon to catenate, we mean carbon to combine with one another to form straight chain, branch chain, and grain-like structure. So carbon can easily combine with one another, as in this case, to form a straight chain, as in this case, branch chain, something of this nature, and grain-like structure, something of this nature. So the ability of carbon to catenate, we mean the ability of carbon to combine with one another to form a straight chain, as in this case, branch chain and grain-like structure. So that's like one of the important reasons why we consider carbon as a major element in the study of organic chemistry. The second reason why we consider carbon as the major element in organic chemistry is the ease with which carbon combine with nitrogen, hydrogen, and the halogen. So carbon can easily combine with nitrogen, carbon can easily combine with hydrogen, carbon can easily combine with the halogen. The third important reason why we consider carbon as a major element in the study of organic chemistry is the ease or the ability of carbon to combine with one another to form a single bond, double bond, and triple bond. So carbon can easily combine with one another to form a single bond, as in this case, a single bond, as in this case. Carbon also can easily combine with one another to form a double bond, as in this case, and it can also combine with one another to form a triple bond, as in this case here. This 1, 2, 3, 4. So 1, 2, 3, 4. So carbon can easily combine with one another to form a double bond, as in this case here, and a single bond, double bond, and triple bond, as in this case here. So these are like the important reason why we consider carbon as the major element in the study of organic chemistry. So at this point now, let's discuss some basic terminologies in the study of organic chemistry. What are these terms we need to be familiar with when it comes to the study of organic chemistry? The basic terminology we need includes some of the basic terminology we'll be looking into. I'll be giving you right now. So when it comes to study of organic chemistry, there are some terms we use. So the first terminology there, that is called basic logy. Some basic terminology in the study of organic chemistry. Number one, we have the homologous series. Number one, we have the homologous series. Let's discuss the concept of homologous series. A homologous series is simply a family of organic compound that follows a regular structural pattern in which successive member differ from the previous by the CH2 group, So I'm saying that homologous series is simply a family of organic compound that follows a regular structural pattern in which successive member differ from previous by the CH2 group. It means that for every new member, if I take away the CH2 group, I will get the previous one. So example of homologous series include the alkane, alkanes, alkenes, alkyne, alkynes, alkanol, haloalkanes. So these are like the example of homologous series ranging from the alkenes, alkanes, alkenes, alkyne, alkanol, haloalkanes. These are like the example of homologous series. Let me explain the concept of homologous series using the alkane. The first member of the alkane is this. So note that for every carbon atom, it must be bonded with 4 hydrogen for it to be stable. So I have 1, so this is 2, 3, and 4. So this is balanced. So this is the first member of the alkane. The second member, let's use 2 carbon atom, 1, 2. So let's balance this. This is 1, 2, 3, 4. So this is 1, 2, 3, 4. Balance. This is 1, 2, 3, 4. This is the second member of the alkanes. Let's use 3 carbon atom. Carbon, carbon, carbon. Let's balance this. This is 1, 2, 3, 4. This one is balanced. This carbon here is balanced. Let's balance this one. 1, 2, 3, 4. Balanced. 1, 2, 3, 4. So I want to explain the concept of homologous series using the alkane. So the alkane ranges from this one, the first member, second member, and third member of the alkane, and it continues in this pattern. So we said when it comes to homologous series, we are saying that it's a family of organic compound that follows a regular structural pattern in which successive member differ from the previous by the what? By CH2 group. It means that for every new member, if we take away C and 2 hydrogen, I will get the previous one. Look at this new member here. If I take away C and these 2 hydrogen here, I will get what? The previous one, which is this one. Observe this one. Let me replace them back. Let me replace it back. C here, H and H. So I'm saying that if I take away, for every new member again, if I take away this C and 2 hydrogen, I will get what? The previous one. I'll get this one here. So that's the concept behind homologous series, a family of organic compounds that follows a regular structural pattern in which successive member differ from the previous by what? Differ from the previous by the CH2 group, as you can see, as I've explained. The second terminology in the study of organic chemistry is simply an alkyl group. What's an alkyl group? An alkyl group is simply a family of organic compound that is derived from the alkane by the loss of 1 hydrogen atom, right? So note that the alkyl group are got from the alkane. So the idea is that without the alkane, there can never be the existence of what? Alkyl group. So why? Because the alkyl group are got or are derived from the alkane by what? The loss of 1 hydrogen atom. So I just said these are the what? These are simply the alkane, right? So this one now is C. This is called C. I have 4 hydrogen here, CH4 as the first member of the alkane. This is 2 carbon atom, C2, 1, 2, 3, 4, 5, 6, H6, 6 hydrogen. For this one here, I have 3 carbon atom, 1, 2, 3, that's C3, then H8, H8, 1, 2, 3, 4, 5, 6, 7, 8. So these are simply the alkanes, as I showed you earlier. So I'm not saying that the alkyl group are got from the or are derived from the alkane by the loss of 1 hydrogen. So it means that if I take away 1 hydrogen here, I'll have CH3. Take away 1 hydrogen from this 4, I'll have H3. For this one here, take away 1 hydrogen here, that's C2, H5. For this one, I'll have C3H7. So observe that the carbon remains the same, but I remove just one hydrogen from this. I will get H5. For this one, H7. This one is H3. So it means that the first member of the alkyl group is simply CH3. The second member is C2H5. While the third member is C3H7. So what do you call this? What do you call CH3? What do you call C2H5? What do you call them? Note that the alkyl group are named after the alkane by substituting the last ANE by YL. So basically I just said that these ones here are simply what? Are simply the alkane. So this one is called methane. It's called methane. This is called ethane. Why this is called propane. So these are alkanes. So the first member of the alkane is called methane, ethane, and propane. So now, what will I call this one? How will I name this? We said the alkyl group are named after the alkane by substituting the last ANE by YL. So I will remove this last ANE. I will replace it by YL. So I'll have methyl. So the first member, which is CH3, is called methyl. The second member, which is this one, take away the last ANE by replace by YL. So I'll have ethyl as the second member of the alkyl group, ethyl. The third member of the alkyl group, replace last ANE by YL. I'll have propyl. So the third member of the alkyl group is simply propyl. This is like the concept behind alkyl group, a family of organic compound that derive from the alkane by the loss of one hydrogen. So this is like the concept of alkyl group. That is called the third terminology of the organic chemistry, which is functional group. Sorry, functional group number 3 there. Functional group. Let us call the third terminology in the study of organic chemistry known as functional group. A functional group is simply an atom or group of atoms known as radical or bond common between a homologous series. It also determines the main chemical properties of that series. When it comes to functional group, we're looking at the single bond, double bond, and triple bond. Very shortly, I will give you a table that contains several homologous series, their general molecular formula, and the functional group, as you can see in front of you. You're welcome. So here are some of the homologous series, their general molecular formula, and their functional group, as you can see the table in front of you. So this ranges from the alkanes, the alkenes, the alkyne, alkanols. So we have like 12 homologous series here, and their general molecular formula and their functional group, as you can see. So we start from the first one is the alkanes. The alkanes. So the alkanes, the general molecular formula for the alkane is simply CnH2n plus 2, while their functional group is simply single bond. So anywhere I'm seeing a single bond is what is an alkane. All right, I'm seeing alkenes here. Alkene, the general molecular formula for the alkane is CnH2n, while the functional group is double bond. So if I'm seeing a double bond, it's simply what there is simply an alkene. So I'm seeing alkyl. An alkyl, the general molecular formula for the alkyl is simply CnH2n minus 2, while the functional group is a triple bond. So anywhere I'm seeing triple bond, is that what is an alkyl. So we have the alkane, alkenes, alkyne. So next up, we have alkanol. So alkanol, the general molecular formula for alkanol is CnH2n plus 1 and OH. So anywhere I'm seeing OH, it represents or it's telling me that I'm dealing with what? Alkanol. All right, alkanol is also called alcohol. Please note that. So if I want to, I can call it alkanol or alcohol. So we have the haloalkanes, which is minus X. Got this one much more later. We have the esters, we have the alkana, also called aldehyde, We have the alkanol, so you can call it alkana or aldehyde. We have the alkanoid, also called ketones, right? If you want to, so the general molecular formula and the functional group here, we have the carboxylic acid, also called alkanoic acid. So it's either I call it carboxylic acid or alkanoic acid. It's very much correct. This is the general molecular formula and the functional group here. We have the esters, we have the amine esters gotten from esterification, which we're going to discuss much more later. We have the amines and the amines. So these are like the 12 homologous series, their general molecular formula and their functional group. Welcome back. The fourth terminology in the study of organic chemistry is simply third and unsaturated hydrocarbon. So let's call the concept of saturated and unsaturated hydrocarbon as the fourth terminology in the study of organic chemistry. Organic compound containing carbon joined only by single covalent bond are said to be saturated, while unsaturated hydrocarbon are simply organic compound that contain carbon-carbon double bond or carbon-carbon triple bond. So I'm saying that the saturated hydrocarbon are simply the alkane. Why the alkane? Because they are single bond. The unsaturated hydrocarbon are simply the alkenes and alkyne. Why the alkenes and alkyne? Because they are double bond and triple bond. So that's the concept behind saturated and unsaturated hydrocarbon. The fifth terminology in the study of organic chemistry is simply the hybridization. Let us call the concept of hybridization as the fifth terminology in the study of organic chemistry. What are hybridization? This is a mixture of two or more orbitals of the same principal quantum number to give a new orbital which are exact equivalent as the orbital known as hybrid orbital. Example of hybrid orbital includes sp cube, or perhaps sp squared, sp cube. These are simply the example of hybridization, right? Hybrid orbital, right? So it's important to note that the alkane are sp cube hybridized, the alkenes are sp squared hybridized, and the alkyne are sp hybridized. So I'm saying that the alkane are sp cube hybridized, the alkenes are sp squared hybridized, and the alkyne are sp hybridized. Aside from this, it's important to note the bond angle. Let me put this into this point here. It's important to note the bond angle for each homologous series here. So for the alkane, the hybridization pattern is sp cube, while the bond angle is simply 109.5 degrees. The bond angle for this one is 120 degrees, while the bond angle for this is 180 degrees. So it's about to know that the alkenes The alkanes are sp cube hybridized and their bond angle is 109.5 degrees. The alkanes are sp squared hybridized, which is 120 degrees, and the alkyne are sp hybridized, which is 180 bond angle degrees. So this is like the concept behind hybridization. So let's discuss one last thing called sigma and pi bond. Let's discuss the concept of sigma and pi bond. So let's discuss the concept of sigma and pi bond. All right, for sigma, what are sigma bond? What are pi bond? Sigma bond is a strongest type of chemical bond common between a single bond, or that can be found between a single bond, right? So it should be noted that sigma bond are stronger while the pi bond are weaker. So in other words, between the sigma bond and pi bond is stronger while the pi bond are weaker. Also note that sigma bond occur or is formed between a single bond. So sigma bond occur in a single bond, while pi bond occur in triple bond and double bond, or double bond and triple bond if you want to. So for the idea of sigma bond and pi bond, in general, if I'm given an organic compound such as this one here, and I'm told to find the number of sigma bonds and pi bonds, how is that done? How can I do that? So note the following, that one single bond produce or gives one sigma bond. So one single bond gives what? One sigma bond. So for every single bond, there's one sigma bond there. Note that one double bond gives one sigma bond and one pi bonds. Finally, note that one triple bond gives one sigma bond and two pi bonds. So as you can see, so for you to know how many sigma bond and pi bond are present in a given organic compound such as this ones here, note that one single bond contain one sigma bond, one double bond contain one sigma bond, one pi bond, one triple bond contain one sigma bond and two pi bonds. All right, example 1 and 2 and 3. We are told to find total number of sigma bond and total number of pi bonds here. So how do you get the total number of sigma bond and total number of pi bond in these three example? Let's get number 1 done. We said from here now, looking at this one now, I'm just seeing single bond all throughout. Single bond, single bond, single bond, single. They are all single bonds here. No double bond. This is a double bond. This is a triple bond. So neither of these two I'm seeing here. I'm just seeing just a single bond. So for a single bond, there's a one sigma bond. So it means let's count the number of sigma bond here and the number of pi bonds. So how many sigma bonds are here and how many pi bonds are here? Now from this one now, we said for every single bond there's a sigma bond. So this is one sigma bond, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So for this one I'm having 13. All right, I'm having 13 sigma bonds. Let's get pi bond. We said pi bond occur in double bond and triple bond. So in this case I'm not having double bond here, I'm not having triple bond, so I'm having zero pi bonds. So I don't have any pi bond here. There's no pi bonds, so 0 pi bond here. All right, let's get this done. Let's come to this one now. Let's do total number of sigma bond, total number of pi bond. First, I'm seeing a double bond here, as you can see. For a double bond contains one sigma and what? One pi bond. So don't forget that a double bond contains what? One sigma and one pi bond. All right, let's get the total number of sigma bond and pi bond here. For sigma bond, count the what? Double bond. So this is a single bond, sorry. Count the single bond. 1, 2, 3, 4, 5. 5. Look at this one. Sigma be 5. This 6. 7, 8, 9, 10, 11, 12, 13, 14. So I'm having what? 14 sigma bond. It is meant to be 13. It is meant to be 13. I can't count this one among it because double bond contains one sigma and one pi. So this one plus the 13, I have 14 sigma bond. Let's get pi bond. We said pi bond occur in double bond and triple bond. In this one here, I can only see double bond. In this one here, no triple bond. So double bond. So I'm having what? Just one pi bond, as you can see. All right, at this point here now, let's get the number of sigma bond and the number of pi bond here. For this one here, this is a double bond, a triple bond. Double bond, we know that a double bond has one sigma and one pi bond. For this triple bond, it has just one sigma and two pi bonds, right? And two pi bond. So let's get to the number of sigma, the number of pi bond. So the number of sigma bond becomes, count the single bonds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm having what? 10, what's it called? Sigma bond. 10 sigma bonds. All right, let's go to the number of pi bond. For pi bond occur in double bond and triple bond. So this is 1 plus 2, that gives 3. So I have 3 pi bonds. So this is how to find the total number of sigma bond and pi bond using the idea of sigma and pi bond concept. So that for one single bond, it's contain what? One sigma bond. One double bond contain one sigma bond, one pi bond. One triple bond contain one sigma bond and two pi bond. In our next class, we'll look at how to name organic compound. See you in our next class. Do well to like this video, subscribe to our channel, and share this video's class to your friend and classmates so that they can learn organic chemistry with ease. See you in our next class. Bye.